Well, welcome everyone to this new webinar from Ystrol. Achieve Perfection, Advanced Methods for Powder Liquid Dispersion. I'm your host, David Howell. With decades of experience and expertise as a leading manufacturer in the process systems and machinery space, Ystrol collaborates with their customers to develop a customized solution that delivers immediate and measurable value. Whether you're in the chemical, pharmaceutical, cosmetic, or food industry, Ystrol have the right solutions for your business, ranging from laboratory scale systems to full scale production equipment. As a medium-sized owned and managed company, excuse me, the strong international presence includes subsidiaries in China, India, and Singapore, and a network of representatives worldwide. Ystrol are well equipped to meet the evolving needs of industry across the globe. Now, today we're considering Conti-TDS, and disperses powders into a liquid in a completely new way. By combining vacuum and high shear technology, particles are separated even before they come into contact with the liquid. This innovative approach results in significantly better outcomes compared to conventional methods, with efficiency and quality dispersion achieved with Conti-TDS are unparalleled, making it a groundbreaking solution in powder processing. Well, today I'm delighted to be joined by Hans Jakob, Senior Expert Process and Applications at Ystrol. Welcome, Hans.
Thank you. Thank you very much for the invitation and for the introduction. Thanks.
Well, many thanks for joining us, Hans. I think this is going to be a very interesting one. I'm sure everyone that's joined us today it's got to wait for your pearls of wisdom, absolutely. We'll see how we go with also questions. Hans is going to give us a presentation, everyone, about what Conti-TDS is and why it's such a groundbreaking innovation. But before he begins, I'd like to also point you all to the box on your screen where you can ask questions. Please do. As we progress through the presentation, I'll maybe asking questions of Hans as well. But if you do have something, maybe you see a slide which you'd like a little bit more detail on, please do leave the questions in the box and I will see them. And you can even come on screen and speak to Hans yourself if you would like to. Well, without further ado then, Hans, what I'd like you to do, if you could share your screen, so we'll kick off the presentation. I say, everyone, if you do have a burning question, please do leave it in the question box. I will see that and I'll put it to Hans. But if you fancy coming on screen, we'd be really happy to see you. So if you could share your screen, Hans, I'll leave the floor to you.
Okay. So
that's great. Yeah, we can see your presentation, Hans. So you're up and running.
Okay, quite good. So then, yeah, also from my side, yeah, thank you that you joined this presentation. Advanced methods for powder liquid dispersion. This is the main topic. Let me tell you a little bit some words about the company where I'm coming from and why we are presenting this topic. We are a company in the southwest of Germany, so very close to France and Switzerland. Yeah. You see that here on the top, on this dot on the map. Yeah, and we are producing machines from lab size to production size for all industry. From you can say from pharmaceutical, also up to chemical industry and even wastewater treatment, everything. And indeed, not only machines, also complete systems. The most typical, or let's say the best known machine from Ystrol, this is our jet stream mixer, a mixer which mixes vertically, not rotation in the tank, because rotation prevents from a good homogeneity in the tank. No, we make vertical mixing. You can see that here on this with these arrows. And typically we are approximately 10, sometimes 30 times, sometimes 90 times faster achieving the complete homogeneity than a traditional mixer. These jet stream mixers are available in a standard form, so in installation from the top, from the side, and also from the bottom of the tank. And they are available in different versions for powder induction. This is our topic today, and also for dispersion, mixing and dispersion as a combination. The second or let's say the second process what we are providing, this is dispersing, high shear dispersing. We make batch dispersers, which could be installed from the top in the tank, which could be installed in the bigger tank from the bottom into the tank, especially when you have other equipment inside. But I must say, these batch dispersers are today uh, they are moved out of the industrial applications because you are very, very limited in applications. And they are not very good mixers. The liquid here
Mm.
around the mixing head is dispersed a couple of hundred times, a little bit further away, maybe 10 times. And then, yeah, let's say here at the top of the liquid, probably not even one time. So
Yeah.
you cannot control how good your product is dispersed, and you cannot control the residence time in the rotor stator because viscosity depending, temperature depending,
Absolutely.
density
Absolutely.
depending. So
Yeah. Yeah.
it makes no sense to use these systems for, let's say, high performance applications. Therefore, we are using inline dispersers. In an inline dispersers, you have similar process, but you control everything: the residence time, the flow rate, the pressure under shear, and so on. And we can make very, very fine um, designed rotor stator systems which give you maximum performance. So this is so to say everything else what we are producing. And now we come to the group of machines what we have for the powder dispersion, powder induction. First system is based on the jet stream mixer,
Hmm.
and the other system is based on the inline disperser. So
And do you
these are
find do you find, Hans, that as you look at your customers, they are absolutely moving their process forward? They're looking at things like liquid and particularly dispersal systems within their process, and they see that they have to evolve that forward. Are you seeing lots of businesses coming to you and asking, this is how we've always done this. Can we do this more efficiently? Can we do this at lower cost?
yeah,
Can we do it more reliably? And
yeah,
these are the systems that people really need to be putting into their process to achieve that.
yeah, of course, definitely. And especially when you need high quality products, when you want to save
Yeah,
time, when you want to save energy, when you want to, let's say, use the full performance of your raw materials.
yeah, indeed.
You would not believe when I tell you people are using, for example, powders which are called bentonite or bentone, or these are sheet silica, and nobody is able to get the full performance because you're not able with traditional technology to delaminate these materials
Of
completely.
course,
This
of
is not
course.
possible.
Yeah,
And
yeah,
this is the first time that you are able to use the full performance is
yeah.
when you use these technologies. Yeah.
Indeed, indeed.
When we talk about powder handling, powder dispersion into liquids, we must know powder is a very specific material. Everybody thinks
Mm,
when we mix powder into a
yeah,
liquid, we are
yeah,
mixing solids into liquids. Uh, this is only the half of the truth. Powder contains air. Powder contains a lot of air. Typically, the volume concentration in a normal powder starts at 75 volume percent air. Typically, it is
yeah,
more, it is 80%,
yeah.
90%. If you have silica powders, fumed silica,
Mm,
then you have
mm.
98% of this powder volume is air.
Yeah,
And
yeah. Oh,
when we are mixing powders into liquids, of course, you don't want to have this air in your product. You want to
indeed,
get rid of this air. Yeah.
indeed,
Another
indeed.
thing is the finer the powders are, the more agglomerated are they. So
Yeah,
this powder here is titanium dioxide, the very common powder in paint
again,
and other
yeah, yeah.
industries. But
Mm,
the powder is completely agglomerated. You will not see single particles. All the particles are agglomerated, even in big pieces like that here. Other powders, then you have agglomerates, in the size of a fist or even bigger. Yeah, so
yeah,
these
absolutely. Mm,
materials must
mm,
be desagglomerated. This is the second one. And the third one, which is important, is powder has a huge, huge surface. Just 1 gram of powder can have a specific surface in the range between 1 square meter up to more than 1,000 square meters. I later show you a video with a
mm.
powder which has 130 square meters per gram silica. And then I
Yeah,
show you a video with a powder which was 1,300 square meters per gram. And
Wow.
this surface is per gram. You do not induct only 1 gram, you do induct a
Of
bag
course. Absolutely.
with
Yeah.
25,000
Of course.
grams. And
Yeah.
so, yeah,
Yeah.
so that means you have millions of square meters, which must be
Yeah.
wetted completely in a
Indeed.
fraction of a second. If you
Yeah.
do not do that, then you have agglomerates in your product. Nobody
Absolutely.
wants
And yeah, powder is very, very interesting material. How you
that. Yeah,
define what that is. But yeah,
yeah,
the thing to get across is absolutely. You look at some maybe your powder substrate, for instance, and you may think that yes, absolutely, we have a very good control over that, but actually,
yeah,
you may not, and that's the interesting thing to pay attention to. The fact that surface area and yeah, most of that's going to be air. It
yeah.
is,
That's right. That's
and
right.
how you manage that's
Yeah,
absolutely vital
yeah,
across your process.
exactly. So um, in the first moment when we think about powder, powder is already a dispersion. It is a dispersion of solid particles
Sure,
in air.
sure.
And now you can say, hey, that it's easy, then we just exchange the air with liquid. But it is in reality, it's not so easy because
Mhm,
we exchange the air. This is correct. But in the powder, the particles are touching each other. When we make
mhm,
a dispersion, they should not touch each other anymore. There must be a distance between the particles, yeah, to avoid agglomerates and to
mhm.
get the full performance what you need. So for that reason, we have to separate the particles to
Indeed.
bring them into a distance. And another difficulty is powder has a bulk density, and the bulk density is in 99% of the cases
Mm,
is the bulk density lower than the liquid density of the liquid, what I have as a basic material where I bring the
I'm with
powder
you.
in. So, and then it happens, of course, that the powder swims on the surface, like here in this
Of
picture,
course. Yeah, yeah.
because it's lighter than the liquid, and we must create a vortex to get it in. A vortex brings also additional air, not only that what we have in the
Mm,
powder. So
yeah.
another difficulty is visible here when you add cocoa powder, for example, in a milk product. Yeah, then the cocoa powder is hydrophobic. It does not want to mix with milk. This is
Mhm,
one thing. So the next thing is it is light. It swims on the top of the liquid. But
indeed.
when we get it into the liquid, and the air is separating from the cocoa powder and going to the top of the liquid, then we create foam. And the last powder we
Yeah,
are throwing on a foam layer, not even on the liquid, just on the foam.
yeah.
And this
Indeed.
is not a good precondition for wetting powders in liquids. The other thing, what you see here, additionally to foam and swimming powder, is um, everything inside the tank, the mixer shaft, the pipes, all installations, the lid of the tank, everything is full with dust. And this is something what we don't want to have. Yeah, dust.
Absolutely. Absolutely.
Dust is risky. It's a risk for health. You need extraction system. You need personal protection.
Mhm,
Um, you have losses when you are handling powders because the powder which goes into this dust extraction cannot be say controlled. Yeah, you
indeed.
lose an uncontrolled amount of powder in the dust extraction. All these things we want to avoid. Yeah, this is what we have to avoid. The traditional way of powder handling is that here, conventional agitator, you have a manhole at the top, you
Mhm.
are adding powder through the manhole. But of course, when you bring a volume into this tank, exactly the same volume must leave the tank.
Of
Yeah,
course.
this is
Yeah.
physics, yes.
Yeah, yeah,
And
yeah.
when this volume leaves the tank, then it comes out as dust, not only as air, it comes out as
Indeed.
dusty air. And this dust is then distributed, especially when you have an agitator motor, the motor with a fan. The fan is distributing you the
Of
dust
course.
everywhere in the
Of course.
room, and you are
Yeah, yeah.
breathing the dust, and this is exactly not what you want. That is something what we have seen in my previous picture photograph. You see the material swimming on the surface. You're
Yeah.
getting crusts everywhere inside the tank. You are mixing air in, air bubbles in, and the liquid is rotating, and you're getting agglomerates. And this is that what we want to avoid. Of course, an idea is to use an let's say an ejector, for example. The
Mhm.
ejector inducts the powder, and with this induction, you do not avoid all these problems inside the tank. That means it's inside the tank, or in respect of powder wetting in the liquid, dispersing in the liquid, it is not an improvement. And if you are very correct, then an ejector is working in pulses: induction, unloading, induction, unloading.
Mm-hmm.
Every time when this valve here closes, the powder in the hose falls back into the bag, down into the bag, and then it creates also dust around the bag. It is not really an improvement, but there are also many other technologies to improve the situation: inline mixers, injectors, other designs. But
Indeed.
this is all not really that what we need. We have developed, this was the first step in the right direction.
Mm-hmm.
We have developed a couple of years ago an injector system directly in such a mixer. And with this injector system, we could induct air in a liquid stream with vacuum, because this is the ring nozzle injector. The ring nozzle injector creates vacuum. We could induct air in the liquid, and this was already a step in the right direction. But
Indeed. Yes.
it was not perfect, because it works only perfect as long as you are filling the tank. When you are recirculating, when you get high viscosities or other already powders in the liquid, then these ring nozzles does not work perfectly. So you can use it only in a single pass. That means the amount of powder is limited, and it is not really dispersing, it's just mixing in. We want to have a better dispersion. We have modified that system. We have created the vacuum here in the mixing head of the jet stream mixer, and we were able to pull powder directly into this mixing head. So this avoids crusts and dust above the liquid surface. And I have a video here, and this is the video with the extreme fine powder. It's an activated carbon with 1,300 square meters per gram. This is the finest activated carbon I ever worked with. And you can see my colleague here inducting the powder from the bag. There is no dust coming out of the bag. We are inducting this black powder. If you would empty the bag in the tank, all the room would be black, and the person as well.
Yeah.
The
don't want to be doing
white
that.
coat. Yeah,
that's
you
good.
know
That's
these rooms. Yeah? But here also
absolutely.
no dust out of the liquid surface, and you can empty the bottom like with a vacuum cleaner completely. So this is very clean, very nice. And this is a good step in the right direction.
Absolutely.
But I must say these systems, they have limitations, because you can use these systems only when you have enough filling level in the tank. That means you need approximately 300, 400 liter level above the mixing head. And we cannot make these mixers as long as we would like to. Yeah, because it's an cantilever design. That means you have here a bearing, another bearing, and then you have a long shaft. And there is a maximum length what you can make.
Yes.
So for that reason, we are limited in so design things. We are limited in viscosities. These systems are working up to 800 millipascal seconds. Higher viscosities are possible, but then they are mixing only around the mixing head where it's easy, and not the complete tank. And they are limited in temperature, for example, 50, 55 degrees Celsius. You are then already close to the vapor pressure, where you cannot get enough vacuum to pull powder through such a long distance.
Okay, fine. But they do have an application. I mean, the technology there absolutely has an application.
Yes, exactly. But we also want to cover all the other applications. Thickeners cannot be inducted with this. Powders would stick on wet surfaces, because the machine is inside wet, so cannot be inducted. We want to do all powders, all viscosities, all products. And for that reason, we developed this design. This is an inline machine outside the tank. It creates also vacuum, but directly here only in this chamber. And not only, I must say, not in the chamber. Later we will see not in the chamber. It is only a section of the chamber where we are creating a really high vacuum, and we can pull powder in directly from bags as
Okay.
well. And this is visible here in my next video. Here you see aerosol 130. This is a fumed silica with 130 grams per square meters. It's a 10 kilogram bag. And we are inducting this bag here. We open the top of the bag and we are inducting. My colleague is opening the powder valve. And from this moment on, the induction starts. You see it here in original speed. And you can see here when the bag starts to collapse, this is
Yeah.
because of the reason. But you see no dust comes
No.
out of the bag. And
No.
after 10, 12 seconds, the bag is half empty already. And
Yeah.
you induct the powder full stream, no dust comes out of the liquid, and such a bag is empty in a minute. Yeah. So that is a typical application of these
Yeah. Yeah.
machines.
Yeah.
They can induct powder, disperse powder in the liquid, and we can also use it from hoppers, from bag tip stations, or for example from big bags, directly out of a big bag, a super sack. This is here a typical design. The machine is installed in a loop. Inside the tank is a jet stream mixer,
Yeah.
which is able to mix the content of the tank completely. What you also see here is we try to avoid dip pipes because we often start with low levels, or we are able to work with low levels and high levels in the tank, and such a dip pipe is not a good design
Yeah.
because it creates a shadow for cleaning, etc. And it makes more sense to go in from the side, subsurface, and ideally on the opposite side of the jet stream mixer, because you will see, I now start the video. You see when the machine is inducting, the dispersion enters the tank here on the other side. It is immediately distributed inside the tank, and we can induct such a big bag, of course, depending on the application, depending on the powder, but it is in the range of 3 to 5 minutes, yeah, sometimes 6 minutes. So this is a typical induction time of a complete big bag, and it is dispersed immediately when it gets in the liquid. It is
Yep.
dispersed. You get a dispersion immediately. Of course, you can, when you close the powder valve, you can use the dispersing performance of this machine for a couple of minutes more, and you
Yeah. Yeah.
can disperse a second recirculation.
But I also, excuse me, I also noticed, Hans, on the previous slide as well, of course, that person had no protective equipment, no green, there's no clean room there. You can do this really in a typical process environment. Obviously, if you do have a clean room, then that's absolutely fine. But it's not a necessity because of literally the fact that you can eliminate the dust issue.
Yeah, of course, when you are working with really, I would say, extreme toxic materials,
Yeah,
then you would
absolutely given.
use personal protection, yeah,
Yeah,
or you would use a bag tipping station which is designed for that. In
absolutely.
pharmaceutical industries, when we are inducting, for example, penicillin, which is a very critical material, you should, of course, definitely not breath any dust when you work with penicillin.
Absolutely.
Then we are working, so to say, the people are, so to say, standing in front of a glass, and you are working, so to say, you see the powder handling behind the glass, and
Yeah.
you can watch that, and you can control everything, but you are not exactly in the same room with the material. Yeah,
No, but
the most,
the process is interesting because it gives you what you're really talking about is the flexibility it gives you.
yeah,
Yeah,
the
because
most,
it applies to everyone. If you're handling any kind of materials
yeah,
like this, whatever the
mo
environment, the technology is absolutely applicable to you.
yeah, David, one of the most toxic powders I ever worked with was pure nicotine. I had to wear a double protection
Yeah,
overall. I have been connected not with to the air, so to say, not with a filter in the room. I was connected to the air from outside, and I
that's
was
fine.
handling
Yeah,
the
yeah,
nicotine powder.
yeah.
These are interesting applications, but I must
Indeed,
say, in
indeed.
most cases, I would really say 99%, it is not that. It is open handling of powder. It is connecting the big bag. We have dust-free connection of the big bag outlet. We have a
Yeah,
double ring docking system so that you do not lose powder, so that you do not create dust.
Indeed.
That is very, very clean.
Absolutely.
Yeah. Today we are also having more and more applications where we get powders from silo trucks, and the
Mm.
silo trucks are unloading in silos. And today we have many applications with flexible silos. These flexible
Sure.
silos costs
Yeah.
compared to a real silo costs, yeah, a minimum. And silos up to 12-meter height we
Mhm.
can install in our assembling area is 12 meters high. But if we have higher flex silos, then we are assembling them directly on site. Here
Oh,
you
okay,
can see a couple of,
it's your approach then has almost been, I guess, a modular approach. The actual system
yes.
itself, excuse me, is a module which will fit into your process.
Exactly. So, and you can, you can start, for example, today with back induction, and then later you decide you go either for big back handling or for such a flex silo solution, or another system is a big hopper. Yeah,
Of course.
a hopper. Typically, powder handling is always the bottleneck in the whole
Yeah.
process,
Yeah.
because it takes time to empty bags and so on and
Indeed.
so on.
Indeed.
And emptying bags, I have explained how fast we are inducting a big bag.
Yep.
Emptying bags cannot be made that fast. Even emptying cannot be big bags cannot be emptied as fast as we induct them. For that reason, it makes really sense to make a hopper. And here in this hopper, you see this company has, or in this case, we are filling the powder in the right sequence of the process. Yeah,
Indeed.
the first powder which are have to be inducted first on the bottom, then the second and the third layer, and on the top, maybe here a small amount of thickener, which is inducted in this process. And when we start, we can fill them from silo trucks, big bags.
Yeah.
And by the
Yeah.
way, the system is a dispersing system. Even liquids and liquid additives are added in the loop, which is much better than adding this on the top of the liquid. An additive in the
Yeah.
loop, or an pH adjuster in the loop,
Of course.
immediately
Of
adjusts
course.
the pH before the liquid comes into the tank. You have no zone with, for example, when you add caustic soda, you have no zone with pH 12. Yeah,
Of course.
because this could be
Yeah.
a big issue in the final product when you
Absolutely.
have here wrong pH zones in somewhere in
Yeah,
the tank.
absolutely. And
Yeah.
with hoppers, Hans, can you give us a sort of feel for what kind of volumes are we talking about?
We make these hoppers according to the requirements of the customer. You
So
can
it's
see here how
completely
on the
flexible.
board,
Absolutely. Yeah.
flexible,
Yeah.
from
Yeah.
smallest hoppers, let's say a couple of liters. Um,
Right.
I
Okay.
must say, when we make these hoppers, in paint industry, a typical size is 4,000, 5,000 liters.
Okay.
Yes, and in other industries, sometimes more.
Okay.
When it is more than, I would say, 5,000, 7,000 liters. In India, we
Mm.
have some applications where we have 15,000 or 20,000, even
Okay.
20,000 liter hoppers in
Wow.
India. But I must say, then it's the question: shouldn't we go to these flex silos? Yeah, yeah,
Yeah,
that is
yeah.
the next step. Yeah,
Let's decide where we draw the line with
yeah,
with the absolute side. But yeah, what your Indian colleagues, that's probably at the upper limit.
yeah,
I would guess, and then you move to
yeah,
a different filling technology. But that's amazing. So it really goes down to, it can be very small amounts
yeah,
of material. So if you do have a ultra specialized process, right up to something that is, it's quite large. The fact that the same dispersion technology can be used,
yeah,
that's very useful, isn't it? Because it just, thinking about your process, if everyone else joins us today, think about what your process is. How could that machine actually fit in, and then
yeah,
transform, in some cases, what you're trying to do with powders. Really very small volumes or even huge volumes. The
yeah,
technology is applicable to both of those.
yeah. And you can induct from every source, where you get the powder from.
Yeah.
We can add liquids in the loop. We can disperse. So I think you are now interested in how the system works in detail. You can see here these videos, but you want to see how it looks inside. So for that reason, I want to open this chamber now in the next
Okay.
slides. Yeah, when we have a closer look to the machine, we see it has 3 connections. One is a liquid inlet, one is the
Yeah.
powder inlet.
Mhm.
And you see here already on this picture that liquid and powder come from opposite sides. This is an important thing. They are not having the chance to get mixed with each other before we let them mix, yeah, so to say.
Absolutely.
And
Yeah.
there is
Exactly.
one
Yeah.
outlet, is a
Mhm.
tangential outlet here back to the tank. When we look inside the chamber, we can see there is a rotor stator system. The rotor is colored red, the stator is colored blue here in this graphic. And you also see here that a little bit already the design of the rotor. The rotor has
Mm.
wings outside the stator.
Uh-huh.
You can imagine there are also wings, many teeth inside the stator. They are not visible here. But what you also see here, there is a disc in the middle of this stator. The stator has this fishbone shape with different slot
Okay.
sizes on the powder induction
All right.
side, on the liquid recirculation side. This is to get the maximum performance out of this machine. But in the middle, there is a disc. And in my next video, you can see this disc rotating.
Yeah,
And you
we can see
see
that.
here how the liquid comes in. Yeah, the liquid comes in here from the backside. We don't see the powder in the moment. The powder comes here from the front, here on this disc, and then the powder is directed, because it cannot get through the disc, it is directed directly into the stator. Yeah, and
Gotcha. Yeah. Yeah.
only in the moment when the liquid and the powder are passing through the stator under highest shear, there we are mixing powder and liquid together. And I want to open this machine here, or I want to cut this machine. I want to show a sectional drawing in this section here.
Okay.
I cut the machine here and I turn it vertical, and then this section looks like this. The
Yeah.
powder comes here from one side.
Yeah. Yeah.
The liquid comes from the back side. Here we have a number of rotors or very fine slots,
Yeah.
depending on the dispersing effect what we want. Then comes the stator with the fine slots, and then comes another part of the rotor. This is this big wing here outside. Interesting is, important for the vacuum
Mm.
is not the stator. Important for the vacuum creation is the difference of the pumping effect inside the stator and outside the stator. You see, the wings here outside the stator is like the impeller, like the wings of an pump impeller. Yeah,
Yeah. Yeah.
a pump impeller pumps because the wings are rotating, and the wings have a specific diameter and a
Indeed.
specific height. And you
Indeed.
see here we have such wings outside the stator and inside
Yeah.
the
Yeah. Yeah.
stator.
Mhm.
Outside the stator, they have a much wider diameter, and inside the stator, small diameter. Outside, 3 times higher height than
Okay.
inside the stator. That means the pumping performance outside the stator is approximately 30 times higher than inside the stator. 30 times higher pumping effect outside than inside. What does it make with the liquid? It wants to get more liquid, but it does not get more because
Okay.
of the rotor
Yep.
design
Yeah.
and
Yeah.
of the other designs here. And for that reason, it creates vacuum. The vacuum is used to pull the liquid with maximum speed, but also the vacuum is also the same vacuum is available here on the dry side of the rotor, and there is powder. And for that reason, we have this high vacuum also on the powder side. And with this
Yeah.
vacuum, we are inducting the powder full speed into the high shear zone. In this shear zone, the gap is 500 micrometers, 1/64th of an inch, 500 micrometers. In this gap, we have a shear speed inside and outside of 25 meters per second. This
Mhm.
is 90 kilometers per hour. And this just to have an impression, yeah, when you're standing on a
Mm.
on a platform in a train station, and the train is passing, you are standing there 1 meter away. Yeah, you cannot stand there because the train with 90 kilometers per hour will push you down. But
Absolutely.
you must imagine if you are there 500 micrometers
Yeah.
in front of that train, and
Yeah.
we are not in air, we are there in liquid stream. So this is enormous, let's say, dispersion effect, where we are
Hmm.
bringing powder and liquid. And this is the reason why we are wetting all single particles. And this is
Yeah.
only one
Hmm.
reason. This is only
Hmm.
one
Hmm.
reason. We are creating a vacuum, and this vacuum can reach, when we are inducting in water, it can reach almost 30 millibar absolute.
Okay.
What does that mean? Powder comes in here with atmospheric pressure somewhere in the bag or in the hopper, and
Hmm.
then here the powder is moving, um, pulled with vacuum, and the vacuum is increasing, and here I have the maximum vacuum. Powder is a mixture of solids in air. Air expands under vacuum, and here, under atmospheric conditions, the particles are touching each other.
Hmm.
But when the air expands 30 times, that means 3 times in this, 3 times in that, and 3 times in that direction. 3 times 3 times 3 is 27. Yeah, this is just a 27 time expansion here
Yeah.
on
Yep.
my. And you see the same
Mm.
particles left and right picture. You see here in original what happens inside the machine. The distance between the particles gets extremely wide, and this led us to easy wet every single particle from outside, completely from outside. That is the trick, and you can see this here in this picture. Very nice. The particles are getting faster, flowing faster, are getting in distance to each other, and when they get in contact with the liquid under this high shear, they are wetted completely. Yeah,
Yes, and
and now,
that's the important thing to get across, isn't it? That when you get to that state where we talked about the surface area of a particle, every area, every surface is now wetted. Every area is now in
yeah,
contact, and
yeah,
that's the
yeah,
important. We've removed the
yeah,
air, which we talked about earlier. That crazy amount of air in
yeah,
some part. Yeah, the particles themselves now are in effect in vacuum, and then we can then look at each surface and then put
yeah.
the whatever liquid or whatever material you need to onto that surface, so you can be with absolute reliability because it's in a vacuum.
Yeah. And David, um, of course, not every particle, let's say, falls apart because of the vacuum. We have
Yeah,
agglomerated materials,
yeah,
and
absolutely.
these agglomerates are particles which have inside um, air. That means between the single solid particles is air, even inside such an agglomerate. But even these agglomerates are wetted completely inside. I show you how. Um, Even such an agglomerated particle, which does not fall apart, comes here with the vacuum, with the increasing vacuum, closer to the induction and dispersion zone. The closer it comes, the stronger is the vacuum, the higher is the vacuum, and vacuum is everywhere, even inside such an agglomerate. That means the air inside the capillaries is expanding
Uh-huh.
in the same way
Yeah, yeah,
like outside. But now, when this agglomerate with inside, which has expanded air inside, when this comes in the wetting zone and it is wetted completely from outside, then
yeah.
this happens under full vacuum, in the
Okay.
moment of the maximum vacuum, and then it goes back to the tank. When it goes back to the tank, it goes back with pressure. Outside here in the circumference of the chamber, we have relatively high pressure. Here we have a vacuum of 33 millibar absolute. Outside we
Mhm.
have a pressure of 4 to 6 bar plus. Yeah,
Yeah.
so that means the air which was a fraction of a millisecond earlier, which was,
Mhm.
so to say, expanded 30 times, it's now
Yeah,
compressed to a
absolutely. Yeah,
size
yeah.
smaller than the original capillary volume,
Of course.
much smaller. And this
Indeed.
is pulling all the liquid into the agglomerate. And that is the reason why we destroy agglomerates as well. Yeah, that is the reason. And this is the principle which is, so to say, available only in our Conti-TDS machines, and which gives them this excellent performance. Yeah. I have we are producing these machines in different sizes. Actually, here you have a list with 6 sizes. Yeah, from Pilotech, we can call this also Conti-TDS 1, 2, 3, 4, 5,
Okay. Yeah.
6, and then comes a
Sure.
jump to 8. Yeah, so that means these sizes are all available in the industry. Let's say in the chemical industry, paint industry, and so a typical size is the Conti-TDS 5. Also in food industry, when you have high um, requirements, high speed
Sure.
requirements.
Sure.
You can see with this machine, you can induct sugar, for example, with up to 700 kilograms per minute.
Yeah.
Yeah, calcium carbonate with up to 600 kilograms per minute. So milk powders, 100 to 200 kilograms per minute. Even 300 is possible, but I must say, uh, attention, you
Okay.
cannot induct every milk powder as fast as you want. But this has other reasons. If you have milk powder application, we must talk about this.
Okay.
Udragit, this
Fair
is
enough.
a coating for tablets, a tablet coating, 200, and
Yeah.
so on and so on. You see,
Yeah.
Expancel, this is the extreme light filler, which is used in polyurethane systems to make it very, very light, but
Yeah.
or
Yeah.
to make a foam product, which is a closed cell foam product. For example, you have this in shoe soles. You have this in a bicycle saddle, for
Yeah.
example, in the
Yeah.
car, yeah,
Yeah.
in parts of the car to make it light, yeah. So Expancel. So this is so extreme light. A bag with 3 kilogram inside has my size. Yes, it's almost as high
Yeah.
as I as
Okay.
high as I
Yeah.
am. So
Yeah.
very, very fine powder,
Yeah.
very, very light powder. It's not fine, it's light
Mm.
powder.
Mm.
Yeah, and thickener 6 to 60. So here we are controlling the speed. Because this depends on the thickener, we do not want to induct thickeners too fast, otherwise we get over concentration, too
Yeah.
high viscosity in the outlet. This is the
Indeed.
Conti 5. This is here a Conti-TDS 3. And the design, what you see here on the left side, is a typical design in food industry,
Mm.
yeah,
Mm.
in dairy applications.
Mm.
Yeah. And
Yeah. Yeah.
you see the most numbers are approximately 33 to 40% of the numbers of the Conti-TDS 5. So the power of the machine is also about 30% of the power of a big Conti-TDS 5. So, but you see, thickeners are inducted with the same speed because we
Yeah.
are
Yeah.
controlling the speed. So
Indeed.
these are the typical industrial ranges, what we
Mm.
have. A typical pilot machine could look like this. This is the Pilotech. And you see here different versions. You can have it as a benchtop machine. You can have it on such a trolley. You
Movable.
can move it around with casters,
Yeah.
or
Yeah.
you
Yeah.
can have it as a fixed installation. Here, even in X protection, ATEX protection, and with exchangeable liquid process tanks.
Yeah.
Yeah, they
Indeed.
can easily be exchangeable powder hoppers or powder handling systems.
Mm.
With this,
Mm.
you can make trials in very, very small sizes.
Do you know, I was about to say that they look incredibly compact. So
Yeah,
if anyone that's joining us today say, well, that might be ideal for either a larger process or a very, very focused process. Something like
yeah,
these could give you a chance to try that out, literally to
yeah,
test that,
yeah,
or in
exactly.
situ, because they're so compact. We're not talking huge changes to plants just to try and test these.
Yeah,
These kinds of machines can be tested, very, very easily, maybe on a small section of your process, just to see how they work for you. I was
yeah,
amazed at how the first one is so compact, yet
yeah.
still gives you the performance which you've been outlining.
Yeah, we have them also as rental machines available. By the way, we have a
Mm,
test center here in Germany, and we have rental machines available which we can send to you. We have the most rental machines are in not X execution, but we have also rental machines in X
mm,
proof execution, so
yeah,
we can
indeed.
cover all this. Yeah, the a picture of the biggest machine I also want to show you. This is
Let's
the
go to the side.
Conti-TDS
Yeah.
8. Yeah. And this machine is typically for the induction from flexible silos in this case,
Yeah.
or
Yeah.
directly also from silo trucks. Yeah, this is
Excellent.
possible with that. Yeah, a machine can be installed not only on one tank, it can be installed on the number of tanks. So you
Okay.
need only one system for the powder handling um, in a couple of existing tanks, or of course, when you have a new system or in a couple of new designed tanks, this is absolutely possible. If the distance between the powder handling area and the liquid is very long, this happens, and we have in
Of course.
between we have
Yeah.
sections where we have, so to say, forklift trucks moving, or
Yep.
there are
Yep. Yeah. Yeah.
walking ways, or
Mm.
yeah, we have also in one application, we are on the other side of a street. Yeah,
Really?
a different house, in a different
Wow.
building,
Complete
we have
different
powder
location.
handling. Yes,
Yeah.
but then we are using pumps, so that the pumps are transferring the liquid to our machines. We make the powder
Yeah.
induction here,
Yeah. Yeah. Yeah.
and then we have another pump which is helping us to pump the material back. This is possible, and it can be also in different levels. Very often we have the situation that
Yeah.
such a
Yeah. Yeah.
machine should be installed on
Yep.
a big tank,
Yep.
but in the previous process, the powder handling was here on this mezzanine floor, yeah, in the upper level.
Mm.
All the
Mm.
equipment, all the people are in the upper level. Of course,
Of course.
nobody wants to go
Yep.
down for powder handling. So for that reason, it's possible to install it in the upper floor.
Where it's
No
needed. Yeah.
problem at all.
Yeah. Yeah.
And what you see here also is, in some industries we have different batch sizes, or we are having premixes. Yeah,
Mm. Mm.
production
Mm.
of cosmetic products or production of home care products,
Yep.
we have often premixes where we are
Right.
premixing some ingredients in a special concentrate, and then this is added into the main mixer. In this case, we can use the same machine for the premixing tank and for the main mixing tank. Yes,
Right.
this
Okay.
is possible.
Yeah.
And
Yeah.
and
Yeah.
also in we have applications, for example, in paint industry, where companies are must be extremely flexible. For example, in the production of coil coatings, you have
Mm.
some coil coatings,
Yep.
um, because for example, an architect has designed a new building, and he needs, for a specific facade, he needs just a couple of 100 liters of these
Yep.
very special coil coatings. The rest is
Something.
a different color, or
Yep.
and for that
Indeed.
reason, you must be flexible. Or in wood coatings, yes, in furniture coatings,
Yeah.
same
Indeed.
story. You need flexibility in batch sizes, and we can make a wide range of batch sizes in one tank. So
Okay.
approximately from 1/5 or 1/6 of the full tank, this is possible. But if you have um, need variations from, for example, from 100 liters to 3,000 liters, then we use one machine between a small and a large tank,
Oil.
and the small tank covers the small
Yeah.
batches, yeah, and then the
Mm.
medium size is covered, so to say, with two small batches, yeah,
Yeah. Yeah.
and
Yeah. 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 Yeah.
the bigger
Yeah.
volumes with the big system. And here
Absolutely.
on this system here on the right side, you can see we have here, in this case, we have a big bag handling, and when you look, yeah, I have only one picture here, but you see here a little bit hidden here behind, there's a back tip station. Yeah, we have back handling, big back handling in this
Again,
system.
it's that modular approach. So
Yeah,
whatever your application is, it's
yeah,
flexible enough. But that machine
yeah,
can be really inserted into either existing, or if you're building a
yeah,
process right now, then now's the time to think about how could that machine maybe make your process more compact,
yeah,
or
yeah,
certainly more efficient.
yeah, yeah. We are facing other problems. Sometimes, you have a dust X powder, but you
Mm,
don't want to have dust X powder in your existing, yeah, process
absolutely.
facility.
Mm,
Then, of course, you make a wall. We can induct through the wall, and then we have here a room which is dust X classified, and here we have a room with no classification or with gas X classification, whatever.
Yeah.
Yeah, this is no problem. Or we have the possibility to induct. I always explain only the induction of powders, but this machine is also used to induct liquids, to make emulsions, to
Indeed.
induct high viscous gels into low viscous liquids, or high viscous fruit mesh material
Yeah.
for the
Yeah.
production of
Indeed.
specific food products. So
Indeed.
this here is a machine in food industry with every connection here is hygienic designed connection,
Yeah.
of course.
Hmm.
And
Hmm.
we are inducting allergens and non-allergens with one machine. Yeah, we don't want to handle the powder on the dry side in the same equipment. Allergen and non-allergen must be
Of course.
separated,
Of course.
but we can clean the liquid side perfectly. So for that reason, we are separating allergen, non-allergen. But here we have a number of other powder materials. You see here,
Of course.
you cannot even see the chamber because of the many valves. Yeah,
Yeah. Yeah. Yeah.
here's
Yeah.
a top view, but here you can see only the allergen and non-allergen side.
Gotcha. Yeah. Yeah.
Results, what we reach are very, very interesting. Here on this slide, you can see three pigments: titanium dioxide, white pigment; yellow oxide, yellow pigment; red oxide. These are all iron oxide, and these are very
Yeah.
agglomerated materials.
Mm. Mm.
Interesting is we reach with
Absolutely.
these machines, we reach a better particle size distribution. The red curve here is with our machine, with Conti-TDS, a finer particle size distribution than in the previous process with the
Hmm.
bead mill.
Yeah.
Yeah. Another example, titanium dioxide. Titanium dioxide is about 60% the most important pigment in all paint industries. Yeah, and for that reason, it is important to disperse this material very good. We
Mm.
can reach particle size distribution. Here you see after 120 seconds dispersion of 370 nanometers,
Yeah.
which is this the medium particle size, which is the original primary particle size of this material
Yeah.
without destroying the surface treatment. And what you see here on the right side is always on the left side, you see, so to say, the previous process. On the right side, you see Conti-TDS process, but with 8% less titanium dioxide. 8% less titanium dioxide. You can see exactly the same reducing strengths. You can also say color
Hmm.
strengths with
Hmm.
less titanium dioxide. You can see a better hiding power. Yeah, here on the right side. That is important. Yeah, when we talk about these applications, when we make colorants, yeah, when
Yeah.
we make colorants
Indeed.
with
Indeed.
our technology, with Istral, we are saving a lot of time. The batch cycle time is reduced 94,
100%.
88, 94%.
Yeah.
This is
Mm.
extreme reduction of time and
Mm.
extreme reduction of energy.
Yeah.
That is such an important effect. We are using a lot of these machines in paint industry
Hmm.
already, but also in generally in chemical industry, and here it's adhesives in the production of adhesives. Yeah, and these are very, very typical applications. You can
Yeah.
see here a system, a
Indeed.
complete system with big bag handling, with additive dosing, with dust extraction system. So this is a very, very clean process. But also in food industry, this system, what you see here, is for the production of baby food, of mashed baby food. But we make also chocolate, energy drinks, in beer production. A lot is in really in dairy application, yogurt drinks or desserts, and recombination of milk. All application in dairy industries are
Indeed.
fields where we have enormous advantages. Another field is, of course, pharmaceutical industry. Yeah, we are making enteral, parenteral nutritions. Yeah, we are inducting the glucose powder, yeah, the dextrose powder, and
Indeed.
we are inducting all the amino acids. We are making the coatings for tablets. This is the biggest field. Coatings for tablets, coating also for retard capsules, cough syrup, many other applications. And another big field is the application in home and personal care products. Yeah, you see
Indeed.
on the left side sun creams, the induction of these, let's say, active ingredients which are, so to say, protecting your skin, yeah, or
Indeed.
many other applications in this field. So I think this was a short introduction in this industry. Yeah. If you have further questions, you can contact us, of course, directly via our web page. Our web page is istral.com. In the United Kingdom, we have recently started with a new partner, with a new presentation in the United States. And you can find our partner here under this website.
Indeed.
And here is the website, and here is the email address. You can send an email to s3@istral.com.
Absolutely.
If you are watching us from United States, Canada, or from Mexico, then our partner in this area is the company PTI, Powder Technologies in the United States.
Indeed.
You can contact them via us, or of course also directly.
Yeah, absolutely. There should be a local contacts within your region. Well, thanks for that, Hans. That was fascinating. Now we've had a couple of questions. The first one, Kat asks, given the increasing focus on sustainability in the coatings industry, how does the Conti-TDS address the challenges of producing high performance coatings, particularly in terms of energy efficiency and dispersion quality compared with traditional methods?
Yeah, of course, this is a topic I could talk more than 1 hour about.
Absolutely.
Just the difference between a dissolver process and Conti-TDS process. But let's say just 3 facts. A dissolver runs with the same shear speed, 25 meters per second, but the distance between dissolver disc and the wall of the tank is 500 millimeter. In our system, 25 meters per second, the distance to the stator is 500 micrometer. We have a shear rate of 50,000 reciprocal seconds, a dissolver 50 reciprocal seconds. The energy concentration, the power concentration. Energy concentration is interesting for let's say for emulsions. The power concentration in a dissolver is typically 10 kilowatt per cubic meter. This is a number, 10 kilowatt per cubic meter.
Sure.
So in our system, we are applying in the machine what you have seen, 90 kilowatt Conti-TDS, these 90 kilowatt on less than a quarter of a liter. The power concentration is not only 1,000 times higher, it's 30,000 times higher. Wow. And another thing is the surface what we are creating. The surface what we are creating, the liquid surface, is in the range between, now let's say roughly about more than 1 million square meters per minute. This is what we are creating as surface for the liquid. This is more liquid surface than powder particle surface. Sure. And when you look into a dissolver, then you are adding all the powders on a surface of 1 square meter. Yeah, you mix it in. Yeah, you pull it down, but it is surrounded by nothing. These are the 3 main differences, and we get a much better performance. I have shown you a little bit with the tinting paste, so differences.
Yeah, indeed. And our second question asks, what kind of improvements in the mixing time have you seen compared with impeller mixers?
This is the probably to one of my first slides. You can typically say, or let's say, example is always the best example. We have a company which is making ketchup. Everybody knows ketchup. They need a lot of sugar in the ketchup. This company is unloading per day 3 silo trucks with 23 tons of sugar, crystalline sugar. They need to dissolve the sugar in a big dissolver, a dissolving tank. They need
Yeah.
for each tank, they need
Indeed.
6 hours. And they came to us and said, hey, how much time can we save with Conti-TDS when we dissolve the sugar with Conti-TDS? I said, okay, we can save something, but your problem is the mixer in the tank. You need a mixer which is
Yeah.
mixing perfectly, which is avoiding the different concentrations. And
Yeah.
then we dissolve the sugar. Listen, we dissolve the sugar in 900 seconds. 900 seconds is a quarter of an hour. And instead of 6 hours. Yeah. So
Yeah.
that is a typical range when you have a dissolving process, but also we have examples in processes where we are making homogeneous mixtures, where you
Yeah.
can really measure the distribution, and this is always approximately a 30th time of the previous process.
That's interesting. Now, interestingly, you've talked about time, but Laura asks about temperature.
Yeah.
Can the mixing also be done at elevated temperatures? And what would that maximum temperature be?
Yeah. At first, generally, yes. I thought the question goes in direction, what is the temperature increase in one passage also? This is very, very low. This is below a half degree centigrade, a half Kelvin, yeah, in one passage. So, but the question at the end was then at what temperatures?
Yeah.
Generally, yes, we must say we we must stay away from the boiling point of the temperature.
Okay.
The closer you come to the boiling point, the lower is the vacuum what you can reach.
I'm with you.
But
Yeah.
we
Yeah.
have
Yeah.
applications where we are inducting in water with 95 degrees Celsius, just
Okay.
below the boiling point.
Just under.
But
Yeah. Yeah.
these applications are with a good flowing powder. This is, by the way, this is the production of fruit preparations for yogurt or for ice cream or for things
Yes.
like this. Yeah,
Good stuff.
fruit preparations are made with pectin. And the idea of these companies is the maximum amount of pectin in a concentrate, but this pectin is mixed with sugar. We can, in this case, we can induct in 95 degrees Celsius.
Okay.
In most cases, I must say 80 degrees Celsius with water. If you have not water, then we must relate this to the, let's say, equivalent vapor pressure levels for your liquid. In oil, for example, oil has a higher vapor pressure. In oil, we can
Yeah.
induct
Yeah. Yeah. Of course.
above 100 degrees. No problem.
Yeah.
No problem.
Now, the next question is interesting. It's also about different kinds of materials. Has the technology been used for dispersing dyes in organic solvents or water? If so,
Yeah.
what type of application?
Yeah. Generally, of course, you know the difference between pigments and dyes is dyes are soluble, pigments are insoluble. But the point is a dye can be a pigment in another liquid. Yeah, because a dye is, for
Yeah, let's
example,
understand that.
soluble
Yeah.
in
Yeah.
alcohol,
Yeah.
but
Yeah.
not
Yeah.
soluble in
Yeah. Yeah. The
alcohol.
way, yeah.
So,
Yeah.
but a dye explains that it is a soluble pigment. Yeah, and of course, this is I'm a, when I came to Israel, I'm working here already more than 30 years. When I came to Israel, and then I started immediately with the development of these machines. And a very, very first prototype was used in a wood coating process, and we
Oh,
were
right. Yeah.
inducting
Yeah.
dyes. And
Yeah.
the company which made the trials here, they were completely surprised because they said, "Oh, they have never seen such a good color development on these wood samples." Yes,
Excellent. Yeah.
and
Yeah.
I was there with the trial machine, and they did not give me back the trial machine. The trial machine has remained there. Yeah, so
We're not having that
that
back.
was successful. But this is more than I would say more than 30 years ago from now.
Oh, they probably owe you some rental money then, I think. Yeah. I would imagine so. Yeah.
Yeah,
Now I've had a final question. This one is yeah, again, it's quite an interesting one. This is a question from a sausage casing production
yeah,
business. Does
yeah.
your rig, can it heat up to 80 degrees C to make up high viscosity food grade gel? And can that then be can that then be degassed for the gel itself? Yeah,
Yeah.
I think that's what. How can you do that within that process?
Yeah. We have applications with these sausage
It's the casings.
the casings. Yeah, we have applications already, successful installations in the industry. So that means this is something what we know. I did not speak about degassing. I forgot that. Sorry. The machine is designed with the rotor stator system, and the last impeller in the chamber. This is acting similar to a centrifuge. And the centrifuge, we have centrifugal accelerations in the range of 1,500 G. 1,500 G. This is very high, but it is not as high as a centrifuge in dairy industry. When in dairy industry, when you are separating a milk fat from the milk, then you are running at 15,000. We have, so to say, factor 10 lower centrifugal forces, but this is enough to separate the air from the liquid. We can separate almost 100% all the air which comes with the powder. So the air goes out as big bubbles, goes to the surface, bloops, and goes away. And you do not create microfoam. That is a good precondition, but it could be when you have a high viscous formulation, and some liquids have the tendency, let's say, to dissolve air in the liquid, and you want to get rid of this air as well, then we need additional vacuum. Then we need a vacuum tank, and we pull that we pull vacuum on that tank at the end of the process. But the most of the air is already gone.
Yeah, absolutely. Okay, Hans. In fact, that's our final question. I think, no one else has dropped anything into the question box. So thanks again for those questions. Fascinating insights into the, I guess, what's happening in your minds as Hans has been speaking. We're at time, unfortunately, everyone. So we'll really have come to the end of what I think you'll agree is a fascinating webinar. This innovative approach results in significantly better outcomes compared to conventional methods. The efficiency and quality of dispersion achieved with the Conti-TDS really is unparalleled, making it really a groundbreaking process for powder handling. To learn more about how Conti-TDS can help you, then please do visit their website, ystrol.com. And as Hans also mentioned, if you're in the UK, please do reach out to s3process.co.uk for more information. Well, until the next time, it's goodbye from me, and it's goodbye from Hans.
Thank you.
And
bye-bye. Thank you for joining.
And we'll absolutely see you all again soon. So do take care.